All right. Good evening, everyone. Trust we are all doing well. We had a wonderful day. First of all, I'd like to actually tender my apology for shifting the time from 4 to 6. That was because I was currently engaged. I thought I would actually be able to make make it, but with the things and it was about to rain, so I just felt like, okay, I can't make this. Let me let you guys know. So I'm really sorry about that. Um, okay, how apologies are accepted. All right, thank you. Okay, so okay, I'll just do a preview of what we did yesterday, and because one thing I know is personally, I know how difficult it is for us to get this thing and make it stick, right? So, one thing that's going to help us is just going over it, going over it, and practice. I can't overemphasize the importance of practice in this, but I'm just going to maybe do a revision, maybe like 10, 15 minutes, then we can go into what we have today and extend it if we have time, right? So like I said, I actually like to take this slow, but then again, I wouldn't want to waste so much time. So okay, so just a recap of what we did. So this is the notebook that we used yesterday. I don't know if anyone can help us with the one we used last week. So all you have to do is just send it because I'm sure you were watching it and you probably practiced. So you just have to send it out. So not like I want to grade it. I just need to combine it together because I want to use a single notebook for everything. So it's going to be easy to revise, right? If you need to go through something, I'm going to make it look nice, right? I'll add some things to it. Then I'm going to add the other one. There was one other one like that. I think. Let me see. It should be my downloads. So I think I shared it on the group. So we can also use that one. Right, but I'm going to try and make this all very looking nice, right, and okay, that it will be very much easy to revise with. So now in the previous this class we started from discussing about lists and how it works again. Then we we looked at the different methods that you can do with a list, right? The different things that are embedded in it, and also we went on to check about the operations, right, that can be done with a list. Then I think it was after then we went to I think we went to tuple. Then we discussed how tuple you can perform some things. So like a list with a list, you can have different multiple data types in it, right? But it has to be enclosed in a square bracket. So with a tuple, it has to be enclosed in a in parentheses or in a curved bracket, right? So that's like the one of the differences. And also we mentioned that the list you can edit it, you can update it, you can insert, you can do it whatever you want to do. It is editable actually, but a tuple is not editable. So that means the operations are limited, right? The things that you can perform are actually limited. And then we did a few examples, right? Uh, sorry, no class finished. Um, Then we went on to discuss about dictionary and how it works, what it looks like. We mentioned that it's a key value pair, right? So for every key, it has a value. So there can't be a key without looking at it. You can actually have an empty value, but it's still going to be a string. So it just came now. Anyways, so let me just try out something. So looking at this now, we have Oxford. So if you call Oxford now, you have Simakili. If I'm going to add another one to this, let's say Oxford, I'm adding something like hi. I can put something like this and enter. If I come back to check Oxford here, you will see hi with an empty space. So that's like I'm trying to just repeat the definition of when I say you can have a you must key value pair, like you must have a key must have a value, right? But that value can be an empty string. This space actually means something in Python. Space is actually something, right? I could have used underscore here. So you see space as something. Let me see if I put a space, an empty, and see what will happen. You can still see it. You still see it as a space. So just to what am I doing? Okay, so what I'm doing is I just assign an empty space enclosed in a quote. So the fact that it's enclosed in a quote is what makes it work, right? So if it was not enclosed in the quotes, if I didn't do anything, if I didn't put anything here, in fact normally I'll get an error from here because there has to be something here. If I just put space, it's not going to see it. So let me delete dots. So yeah, so that's how a key value is. So a key must have a value. A value belongs to a key. They can't be together. And we talked about the different ways you can deal with the different operations that can be performed with a dictionary. So I also mentioned that a dictionary, a list, and a tuple, they are kind of alike, right? They have similar things. Also, they have things that makes them different, right? Things that make them stand out. List is a square bracket. A tuple is with a curved bracket or parenthesis. Your dictionary is with a curly bracket. I call them curly brackets. I think I call them curly braces. Yeah, you could hear it as curly brackets or curly braces, right? So, but I choose curly brackets. That's where I see it. So, that's basically so the different operations that can be performed with a dictionary, right? You can see it here. I also mentioned all these things can be different, right? If you go through the other one, I don't know if I shared this. If you go through this, you'll find out. I think if you get to the data types, you'll find more examples here that you can relate with. I think this set, I wouldn't want us to touch that. The bit subtle. This is a list. Oh, okay, yeah, I think I remember now. Uh, so I'll come back to this. So this is a list actually, and you can see, I think there's a part, there was a part I saw a very, okay, yeah, good. This is it. So fruits, fruit has this in it. Mixed list has number, text, boolean, float in it. You can see this. This is more of like a coordinate. Coordinate is storing a tuple. So you might wonder why do we even need tuple? So you can see this is an example of using a tuple for coordinates. Coordinates, you don't need to change coordinates. Coordinates do not need to be changed. The coordinate of a place is supposed to remain the same. So when you're dealing with those kind of things, you don't want to use a list. You want to use a tuple because the tuple it's not going to change, right? Okay, this is like a dictionary. You can see a name, Bob, age 25, grade A. That means this, let's say, is a student, for instance. Now, so the name of this person details is Bob. His age is 25. His grade is A. So maybe the grade for a particular course. Or looking at this employee info now. So that means like now we are storing an employee info here. Name Carol. Position is a manager, and salary is 60,000. I don't even know, maybe $60,000, 60,000 naira or pounds. So that's just to give you a feel of how a list work, or how a dictionary work, or how a tuple work. So so basically that's it. So I mentioned that I missed something yesterday. That was two commands. So that was append and remove. So if I'm just going to go back up, I can slot it in into this. So I think I used remove, so it was just append. I knew it was, I think it's even five. So append. So let me use this bad example. Okay, I think I can stop this and then start running from the beginning. No, then stop. Restart the kernel. Restart. So I'm restarting everything, and if I run this, it starts from one. So I need this bag. So I want to use bag as an example, or I think I should just create a new one. Let me see where this ends. I'll just run it down. So you can see what I'm using here is Shift Enter. So Shift Enter is what is running all of this thing. So I'm just going to Shift Enter and continue to where I think I want to stop. Right. So I'm just, like I said, I'm just going to add it. Let me just add it to this. So I think when I get there, where is it? Okay, yeah, where I'm starting with couple, and I'll use Alt Enter. So Alt Enter will create a new one and not move to the next one. So with the append function, so what does the append do? Append is very simple actually. Append, from the word append, like you're trying to add something right into. So look at, let's say there's a queue in a cafe. You guys want to get a coffee. There are 10 people on the queue that want to get the coffee, and they say the cafe owner says, oh, this place is closed, we're no longer accepting anybody. If someone comes in and say, oh, sorry, I need to get a cup of coffee, and the owner says, oh, because it's you, maybe he knows the person, and because it's you, oh, yeah, come inside. So when the person comes inside, that person is going to queue and stay at the back of the last person. Now that's what like append means. It means that we are taking an additional thing and we are just automatically putting it to the end, to the last place. So it's like first come, first serve, that kind of thing. But we are just putting the last, we are focused on the last person, right? So now let's look at, let me just use bag. So bag has textbook, pencil, sharp. Okay, I think there's an example here that I want to steal. Uh, so I'm not going to, I'm just going to copy everything. Uh, so I have it here. Let me do. So now fruits is now created. So if you check what fruit is, fruit comes out as this, right? Now I want to add another fruit to this. That is when I have to use append. So all I have to do is call fruit dot append, and in this I'm going to put what I want to add. So what fruit am I adding? Let's say uh cherry is here, banana is here, carrots. So let's say carrots. Yeah, so if I run this now, you're not going to see any outputs. But if I check it again, you find out that we now have carrots added to the end of this. So you know that with insert, you have to put in the particular position that you want. But with this, you just have to add in the last one. Just put it, use append, it will put it to the last. That's all. That's all you need actually. So that's basically how it works. So I can do another example. So let's say with the bag dot append. What do we want to add? Let's say we have textbook. That's here. We have textbook. We have sharpener. We have pencil and sharpener. So what can we add? I can add a water bottle and shift enter. Now, of course, you're not getting any response. But if I run this now, you find out that we have textbook now. You can see pencil, you can see sharpener. You can see that the water bottle we just added is now there. So let's say, oh, my water bottle is joined together. If you check this in the English word, it doesn't mean anything. Let me change it. So all I have to do is access the index. So 0, 1, 2, 3. That's the third one. I put 3 here. So if I call this, of course, water bottle will come out. So I want to now assign something to this. So what I'm assigning now is water with a space and bottle and shift enter. So we don't know if that worked, but we can check, and you can see now that it has changed from water without space to water bottle with space. So you can see the difference now. So that's how the append works actually. I'm not doing this one. So that's how the append works. Of course, there are even older ones. There are multiple ones, right? Uh, there's there's sorting how you can sort these. You can maybe sort it in ascending. You can sort it in descending. But as we proceed, when the need arises, we get to. I just want us to stick with this, like understand how this works, how the possibilities, anyways, right? It's actually endless. It's bigger, right? You can do anything.
Excuse me, please, I have a
Yes.
question.
Okay.
I actually wanted to ask a question about underscore, the use of underscore when we're doing lists. But I realized that this is also a list, but I realized that you didn't use underscore, but we've always been using underscore. So are you saying it's not compulsory to separate um, words with underscore?
Okay. So, hmm, regarding using underscore, for your variables. Now, there are two different things. If I try to, so let's do something simple. So if I try to put water bottle, sorry, water bottle equals to, um, let me say rag. So now look at this. I'm using, if you look at this, if I run this, of course, what would you call this? This would be seen as a variable. This water bottle here is seen as a variable, right? Now, I used the underscore to join these two statements together so that it sees it as a continuous statement, like something that is is continuous. Now, let me try to put a break and use space here, and I use shift enter. You can see that there's an error. Now, the reason why you get an error is that Python is saying water as something separate. So it's saying this as two disjointed things, water and bottle. They are not connected, right? So it's like, oh, if you have water, then you should have, if you have this statement, maybe you are supposed to have something that connects to this, but you don't have any of that. You just have something separate like this. Okay, let me reverse this situation. So I'm going to leave, I'll take out this bottle. Oh, imagine, okay, I think I'll take out this bottle. I'll leave water. I'll come to rag and I'll put pot here, to rag pot. Now, if I run this now, this will work because everything is enclosed in a quote. And in Python, it is saying it as a string. Now, that means that you can have rag bots, you can even have not, it will work, right? Because they are all enclosed inside this string. But if the minute I remove this string, of course, it's not even going to work. You can see that. Let me try it. You can see there's even an error already. So, in fact, not is not going to even work. So, there's the difference between underscore and space is that um, when you are writing your variables, you cannot put a space in between. For instance, now I need to do something like I need to create a variable. Let's say shorthand, right? Shorthand. I can't do this because it's going to be seen as a disjointed thing. But because I want to name my variable like this, I don't want to. I can actually do it like this: shorthand, and join it together. But you might not easily read it, right? But if I do it like this, you see it as, oh, this is easily seen as short and, right? So that's like why we actually try to use underscore a lot, right? Although there's another way, and I think that's under variable naming concepts. So this shorthand is like, the short is, they call it snake case, snake naming concept. Snake case, you use a snake case to name your variable, so it looks like a snake, but we are not doing that. We use this, so we separate it by underscore. I think I've forgotten what this is called. So that's actually the difference between uh using um space and underscore. So there's no underscore here because even if I put an underscore, it still would work. It still would not work. Sorry, it will still work anyways. Using an underscore, using a, of course, you can use this, right? Just for to make sure you get accustomed to using underscore, because underscore is like one thing you get to use a lot, especially if you want to create a long variable, right? So you might need to actually use something like this. That's actually why we use underscore a lot. I hope that's actually clear. Right. Okay, so now I think I did not plan for it to go this way. Um so the next thing that I was actually planning for us to go into, it's different from the list, tuple and dictionary. So let me start a new row below. Ah, no, I'm still here. Okay, I want to be here and use this. So the what I actually want us to do today is conditionals. I'm sure it sounds familiar. So conditionals. So conditionals. You remember from Excel, if else. You remember from we did it in Excel, we did it in SQL, we did conditionals. So this is what I want to actually look into. So we are going to be actually dealing with conditionals. So the fact that we actually have an experience, I believe this should be a very smooth ride. Maybe just understanding the syntax, but we understand the concept of if else. That is to say, if this thing is true, um do this, and if it is not true, don't do that. We don't do this, or if it's not true, do this instead. So like if I'm going to, I think I can't remember the analogy I used there. I actually cannot remember. So but I would like to use another example. So like let's say if I am going out, okay, if it's going to fall today, if rain is going to fall today, take an umbrella. Else, don't take an umbrella. So it just simply means that if I'm going out and rain is going to fall, I'm to take an umbrella. And if the rain does not fall, I should not take an umbrella. That was like just two things, right? Checking in between. If one is true, do this. If this is not true, if that first one is not now true, do this instead. So that's the idea behind conditional. So that's just to refresh us on that. And it could also be another, it could be an extended conditional where we have, let's say, there are three possibilities. So I'm trying to look at a possibility. Oh, okay, good. So if rain is going to fall, right, take an umbrella. Now if rain does not fall but the sun comes out, right, maybe I have a car, and so the next one is, if rain does not fall but it's sunny, ride my car, take my car out. And if it is not raining, if the sun is not scorching, then I should what? I should not take anything. I should go out I should go out without my umbrella and without my car. So that was like a three conditional statements. Like I just attached three conditions. If I'm going out and it's raining, take my umbrella. If I'm going out, it's not raining, but the sun is out, take my car out. And if the first two does not work, I would have to follow the last one, which is don't take anything else, just go out like that. So that's me talking about extended, like extending the conditioner, so it can actually be extended. Now, having understood this, um, I'm going to take us through the implementation, how it works in Python, since we are a bit familiar with the concept. Now, in Python, right? So we call it, it's still if, but we call it if else loop. So it's like a loop. Just go through this. If this one does not work, go to the next one. So to do that, Oh my god. Ah, I forgot. Okay, so let's hold on the on this word conditionals. I've explained the condition. I'll come back to the implementation, but I need to show us something real quick. So there's something called uh keywords. Uh, Keywords. So I think I have a way to make this bigger. Oh my god. Oh, okay. And now, yeah. Um, don't mind me. This is just syntax. Yeah. So keywords. Now we have, what is a keyword? A keyword is a set of words in Python that are dedicated already to a particular thing. They are dedicated to handling a particular task. For instance, now when I tried to put not the other time, you can see that the not has a different color. If I try to put maybe not with a capital letter N, you are not going to see that color. If I try to use a word like if, you see that color. If I try to use an and with small letter A, you see the color. If I try to use true with small letter T, you won't see it. But if I use capital letter T, you'll see it. And the reason why you are seeing it with with capital letter T and you're not seeing it with small letter T is because Python is case sensitive. You understand that? So I'm just going to bring out the keywords. I think I should get an image. Keywords in Python. I think there are a bit. I think about 32 of them or 28. Um, let me see if I can just get an image. Um, okay, let me put all keywords. Actually, yeah, I don't think we can do all keywords, but at least we can see the basic keywords that are there. Let me see. I think this will just do. I can copy this image and bring it here, so I can embed it into. Uh, yeah, people use this for slideshows. So I think I should just bring it here. Yeah, so this is it. It might not be clear enough, so I think I'll just stick to this place a bit. So let me just use it. So I should have it here now. So I mentioned that keyword is uh, a set of words that are dedicated to doing a particular thing in Python. They mean something, and because they have been dedicated to doing something, you cannot use those words as variable. You cannot use it as a variable name. For instance, I want to create a variable and I decide that, oh, I want to use maybe true. But let's say I want to use if as my variable. No, that wouldn't work. Or I want to use what's here? Maybe false or assets or from as my keyword. That would not work because it already have a dedicated function. It has a dedicated thing that is meant to do. So that's what basically differs why what we have with keywords. Um, I don't know. I think there might be a way I can even bring it out in Python. Let me see. Oh, okay. I think this is better way I can bring this out. Keywords. Keyword is not defined, of course. I'm in the Python kernel. This person used the Python kernel. Welcome to Python. Okay. This might not work. Okay, maybe I'll see. Because for me, I just knew it over time and using some nice editor to edit. When you type a command, you can, oh, this is the keyword, I can't use this. So maybe over time we get to see what are those keywords. But I think I can explain a bit. Let me try. So this looks bigger. So we have y, we have false. No, this is not correct. False is with capital letter F. Yes, capital letter F. So this is false. There's none, there's true, there's and, there's as, there's class. You can see all of them. So these words are restricted from using them as variables. But like I said, they mean different things. So we'll get to see what they actually mean as we proceed. Uh, so having explained what a keyword is, right? I think I can now go to conditionals. So that means when you saw del, you can see that del is a keyword. Which other one did we use? I think that was just it. The rest were inbuilt functions. I think that was I think that was it. Yeah, I think that was the only keyword we used yesterday. So I wanted to use a new one, which was why I felt like, okay, let me first of all explain um, keywords to understand what a keyword is. So when you understand what a keyword is now to back to conditionals, right? If you want to create a conditional, you need to write use the syntax um, if. So the way it works is if, sorry, small letter, if this, right? That means if whatever you have here is true, then you put a colon, then okay, I think now if you do okay, I think I should just create an example, then we can explain it properly. So let me just start. So if let me say I have a variable called uh what do I want to use? Bag. Let me see bag. I've used bag already. Let me see. What can I use? Home. Let me use home small letter M H. So home. So in a home, let's just say we have just one thing. Is a string gas. Now what I want to check now is if this gas is in this home. So what I'm just going to say is if gas if home equals gas, then prints true, sorry, C capital letter TRUE, and else prints false. Okay, so I'm going to run this now, and you see true. And if I change this output to SAS and I run this, you get a false. Now let me go over it and explain what I've just done. So the way the Python works is like you have to write an if statement, right? If else. So if space, right? This is a variable. I'm using double equals to. So double equals to is a comparison operator. So that's a new one. So double equals to is a comparison operator. What does it do? You use it to compare two things together. So you are trying to check, is this equals to this? So you already know that the first, if you are using a single equals to sign, that means if you are using a single equals to sign, it is an assignment operator. That means you want to assign something, like let's say Farah is, let's say um bandwagon. So that means we are trying to assign bandwagon as a string towards Farah. That means that anyway we call Farah will get bandwagon. But if you are using double equals to, since the single one has been taken for assignment, so all I think the people that developed Python did was add another equals to sign to make it a comparison. So that means you can now check two things. Let's say, let me use simple stuff. Like one equals to one, right? If I run this, I'll get a true. Is two equals to three, you get a false, right? Is bag is bag equals to bag, get it true. If I change this to D, dag, get a false. So you can see how you can now compare two things together in Python. Like, and the output is Boolean, either it's a true or a false. It's just one of the two actually. Uh, so that's basically how the comparison of vector work. I think I should hold on here and see if you have any questions before we go into the conditionals and explain. If I go ahead to explain, or maybe I should just explain it, then we can take the questions on this together. So now what I did here was this ohm is it equals to gas. Now you can actually come here. So already I've assigned something to ohm, which is SAS. Let me say, let me put it back. Let me even put something different. Broom. So ohm is broom. Broom is equals to ohm. Now if you check ohm here now, you get what? Broom. Now if you try to compare this with another string normally, you would say, let's say gas, like we did up here. Now I'm taking this statement and bringing it down here. So if you singularize it, so you're checking is ohm equals to gas. What's the answer? False. So if I include this into this loop now, so I'm asking, is ohm equals to gas? Now I have to put a semicolon because if I'm using an if statement, when I'm done with putting the statement, the thing I'm checking, I have to end with a semicolon. And immediately I end with a semicolon and I hit the enter button to go to the next line, it comes 4 spaces away and start a new one. Now I'm going to explain the reason why it does that in a bit, but let's just assume it does this, and you put your print statement true, and when you're done with the first one, that means if this is true, right, whatever you have under it will print, will be executed. Let me put it that way. Now if it is not true, this is where you now need an else. I can decide to remove this and just do this. Nothing will come out because ohm is not equal to gas. Ohm is broom and broom is not equal to gas. So this did not work and it did not output anything. That's why you didn't see any output. So I'm just going to return this back. That was Ctrl Z anyways. So I have to now add an else statement. So in case this does not work, I'll add an else. Now with this else, I'm going to say so immediately and I have to press an enter button. Sorry, hold on. So I have to press an enter button here. So when I press an enter button, it's actually will come down normally. But because the else has to be on the same line with the if, so I have to take it back, which is what I did here. So I took it back, and like I said, the if and the else works alike. So since the if has this, so the else has to have this also. So it has a semicolon, and immediately you put this automatically anywhere in Python. So I don't mean anywhere actually, sorry. So I mean anywhere you are using if, like you write something like this, if this is this, you put the semicolon and you press enter, it will take you, your next line is going to go down. That's actually how it works in a standard way. I would call it in whatever. So for instance, we are using Jupyter Notebook. So if you are using something else, there are different ones you can use. So if you are using an editor that does not support all of these things, it might not do that for you. So you might have to do it automatically. You might have to do it manually. And doing it manually means that you have to put 4 spaces. So normally if I press enter here, sorry, if I put it, it's going to come out like, so I have to put 1, 2, 3, 4 to set it in place actually. If not, it will not run. I'll have an error. So if I put 2 or even 3 safe and I run this, no, hold on. Let's change it back to gas. So we want this one to run, this statement here. So I'll change it to gas and run it. Okay, it's not supposed to run actually. Um, well, funny enough, it's running, but this will not work. Maybe Jupyter Notebook is actually helping us, but it should not work. So 1, 2, 3, 4 is what we are supposed to do. Then we print true, else, and print false. So this is just the syntax. So this just means that if this is true, run this. Now this can be multiple things. It can have a lot actually, right? I can have after print true, print. I'm using print because print is easier to relate with. Print um the home, the home is gas. You know, I can add print. Oh, I'm happy. I am happy. And else, if this first one is not true, run this else and print whatever is there. So print false, print the home is not gas. Oh, then print I am not happy. Now if I run this now, you see that the first this what I'm getting here is this one that work. That means truly home is gas. Home is equals to gas, and that's why you have this here. So if I change this now slightly by, let's say I make a mistake and even put space at the end of this, it will work because Python sees them as two different things. So this gas already has a space now. This one did not have a space. So running this two now, after running this and checking this, so I want to see if this is equal to that's what's happening. So is home equals to this gas? No, because this one has a space. So what will happen? This will not run and this will run. So that's how it's actually going to that's actually how it's going to actually run basically. uh I think I would hold on here a bit. So I would like to see take any questions that we have, any concerns, any doubts, anything at all. Or uh are we getting to we are still trying to wrap our head around it. um okay, I'm going to assume that that's a that's a yes. Sorry, that means we have no questions. Okay, so being that's been the case, um I can probably go ahead to do something interesting. So let's look at a very fine example. Now we want to look at a situation where, so now we are beginning to think, um think like think about something and try to apply it to Python, right? Try to solve it with a computer. So I have normally, let's say I'm in a school where there's I have students, right? They have exams, and the way it works is you have to have 60 over 100 to pass. That's all. Just have 60 over 100. So if you don't have 60 over 100, you fail. Pass to pass means over 60. Oh, it has to be 60 and above because 60 is included. Please pay attention to that. 60 is actually what's included. So if 60 is not there, and if it's 59 and below, then that is a what? A fail. Now let's see how we can bring that into Python. So we need a variable to store our results. So we call it results. I think it's coming now. So results can assign anything to. So let's say for now we are just saying 59. right? So result equals to 59. So let's go to the next uh tab and create something. So we are going to use if else. So the question is, if this result is what greater than what, uh if sorry, just 1 second. No, it's not yours. No, 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 no. I brought it from home. I bought it with this. All right, sorry about that. So so we want to check if results is greater or equals to 50, equals to 60. Then I use a semicolon, right? Remember the syntax. When I press enter, it comes down. So what is happening here is indentation. It's called indentation. So like let me put it in indentation. Sorry, I think this is it. So it is called indentation. So indentation is basically um four spaces basically. So like when you are dealing with something like this, like if we'll get to see there are other places where indentations applies. When you get to when you have something like this colon, what comes next has to be four space in the next line basically. So if result is greater than or equals to 60, what then happens? You can say print um you have passed. You have passed. You can say congratulations, make it look good. Congratulations, you have passed. And if not, that will be else, right? And a column, and you hit enter, and it creates a new one, and you put print oh sorry, um we sorry you didn't pass. Let me put, so you didn't, sorry, so you didn't pass, right? So if I run this now, you see, oh sorry, you didn't pass because the result is 59. If I change these results to 60 now, you see that the output has changed. Congratulations, you have passed. So I'm sure you must have seen some of this kind of thing on websites, maybe where there's a grading system, that kind of thing, that you have to get a particular result, a particular score to get a part, and you see a particular responses. So this is how it's actually being generated, right? So all the answers you just do it like this, right? So if all you have to do is just change these results, because I'm already passing the results is not a variable I'm using here. So I can change this to 0. You already know what will happen. Oh, sorry, didn't pass. So that is like using something that we can relate with, right? So now I was going to mention that results greater than or equals to, because if you use only greater than and you put 60 here and you run this, you're going to get, oh sorry, you didn't pass, because results greater than 60. So let's try it. Results greater than what? 60. You see false. That means result is not greater than 60. That means 60 is not greater than 60, but 60 is equals to what? 60. So in that situation, you need to include 60 into it, unless you are going to have it like is results greater than what? 59. So let me just, I don't want to export. So we just have two versions, and this will be greater than 59. Sorry, I missed. Good. So this will be greater than what? 59. So is results greater than 59? Is 60 greater than 59? Yes. So if I come this and run this, say congratulations, you have passed. So that's using a variable. Okay, I think here we also use the variable, right? That's using a variable here. to describe how in particular you can actually use this in relating to something, natural, something that is natural that you can bring to the computer. So imagine a list. Imagine you trying to maybe mark the script of, okay, you have even marked it, you have recorded your script in an Excel file, right? And you now have to start checking, oh, did this one pass? Did this one not pass? Did this one pass? Right? You have to do that 100 times. And if you are doing it for one, maybe in 1 minute, you do it in 100 minutes. And 100 minutes is 1 hour and 40 minutes. That's almost 2 hours, basically. So you can't. So doing this will actually be faster. You just have to write something like this and, oh, check if the result here is greater than 60. If it is, tell them just print or store it somewhere, maybe in the next tab you have passed to, or output their name, or send it an email, or send them a message, something about that. So that's how the if else sorry, this is how this conditional it is actually a simple conditional statement, actually a conditional loop. Yes, it's a simple conditional loop actually. Um Now, having known this, hmm, there's now, remember I was talking about the aspect of using uh for instance, if I'm going out, if it's raining, take an umbrella. If it's not raining and the sun is scorching, take my car out. And if nothing is happening, don't do anything. We are going to implement that now actually. So what we actually use is a bit extended, right, for this. So the way it works is we have if, so let's say I store weather. So let's say weather condition. So Tito that was asking, you can see here I have to use underscore weather condition. So let's say weather condition here is rain. Now I want to check. What would I do? If weather condition, that's the variable, equals what? Rain. That means I want to first of all check for rain, right? So if it is equals to rain, print what? Take an umbrella. Take an umbrella. Take an umbrella. Now, if it does not rain, that means this will not run. But we want to check, okay, it's not raining. What if the sun is out? Now, how are we going to do that? There's another keyword in Python that we can actually use, which is elif. So elif is a combination of else and if. So I'm going to write this in a simple way. So sorry, hold on, please. No, no, like the noise. I'm recording. All right, sorry about that. So so what I was actually want to say is before I do this, let me implement the uh the simple one. So the simple one we know is else, right? We'll do this. Now, if you want to now extend this now, sorry. All right, so sorry about the interruption. Now I'm going to use if else normal. So if weather condition is rain, print this. Now I'm putting an else. So inside this else I'm going to use another if statement and say, oh, we want to check if the weather condition is what? Sunny, right? So if this weather condition is sunny, and if it's sunny, print take your car out. Take your car house. Now there's something that's happened here. Remember that we used a semicolon here and it created this. Now we are using another if statement here. Putting a semicolon here will actually create another one under this. So already, if I'm here and I keep pressing enter, it will keep going down. But if I had another one, it's going to take me to like 4 spaces after this one. You can see how it is. If I had another one, it just keep going. So that's like just explaining indentation. So, but we don't really need to bother about that since we are using Jupyter. It will sort it all out. So I just wanted to clear the doubts about this. So now I'm using if here. If weather condition is actually equals to sunny, then I have this. Now under this now I have to include another else because um if this weather condition is not sunny, then what happens? Uh, let's say go out like that. Print. Um, you can go out. Yeah, so you can just go out. So you can just use this. So now, if I'm going to explain this now from the beginning, so let me just explain it from the beginning what I've done. So what I've done here is I'm checking it for the first statement if it is equals to rain. If it is raining, now if it is raining, this will be executed. Sorry, hold on. This will be executed. Hold on, I'm making a mistake. This will be executed. Now, if if it's not raining, I mean if this condition is not true, then else. Now inside the else, we still want to check for other things. We are not done. We still want to check if the weather is sunny, which is why we have to use another if after the else. And we put it like if this weather condition is now sunny, print take your car out. Else, if this is not now sunny, then you can go out freely. So if I run this now, you're going to see pick an umbrella. If I change this to sunny now, sunny, and I run this, you see take your car out. And if I change it to say, let's say normal, you're going to see that you can just go out. So that's actually how you actually, if you are going to implement multiple. So if I want to extend this, all I have to do is just come here. So after this if else, right? So rather than print you can go out here, I can check for another condition, but let's just hold on like this and leave it like this. Oh, okay, let me extend this. So let's say else. So I have to clean this. Oh, let me just take it down. Let me comment it out. So else, if the weather condition, uh, if the weather condition is what weather condition is running? Okay, snowy. Snow, snowy. Let me just I don't know if this is something, but let me just say it like this. So if it is snowy, then go out with your coat. So print go out with your coat, and else print what? Now I can bring this back. I can bring it back now. So if I change this now to snowy, okay, let's run it from the beginning again. Rain, take an umbrella. If I use sunny, take your car out. If I use snowy, go out with your coats. And if I use anything else that is not rain, that is not sunny, and that is not snowy, if I use anything else, maybe uh sun and rain, you can, okay, I should even put you can't go out. Let me just put you can't go out, right? So you can't go out. Let's restrict the person. So that's actually how actually how it works, right? So if the weather condition equals to rain, print this. Else, So it's more like you are embedding if else into another else. And what is making this possible because of this else? So the else means if the first one is not true, then using this means that, oh, you still have other conditions to check for. So execute this one, then print this if it works. And if it does not work, use an else. After this else, you are now putting on that if because we are not done. We still have another condition to check. Then you use this whether condition equals to what? No, right? And you check this, and you actually what? Print. And if this does not work, that means, oh, you are the final one. You don't have any condition to check. So you just go ahead and what? Print. Oh, you can't go out. And that's when you run this and you get your output. Um, do we have any questions? Okay. Okay. So I believe we are following. We are getting along. Okay. So let me now move to. So this is if else and embedded like and I'll refer to it as an extended if else and if else loop just to handle the extra conditions that we have. But there's a cleaner way to do this, there's a better way to do this. Because imagine I have a lot of conditions, then this is going to be like it's going to be going should I say like a triangle. This will keep drawing, right? And you keep going and keep going and keep expanding. Um but there's a better way to do this. And the better way to do this is, so I'm just going to copy all of this, right, and bring it here. Now, I introduced something earlier. That's what L if, EL and if. So it's actually just combining these two together. So it's like let me see. It's like saying that you have else plus if, but this time around you are removing the s, right? So you're having I'm just trying to show something like how it came out so you can see that you're having this. So basically just joining together. So if you want to now do that here, what I will have to do is take this, clean it. I'm going to have elif. What do I do here to also take this, um take it out, right? Then bring this back and I'll bring this back. So what I'm going to use shift tab. Tab will take it to the front by 4 spaces. Shift tab will reverse it. Then also shift tab for this. And also shift tab for this. That's on my computer. That's a shortcut. So just rather than using backspace, you can just use that command to do multiple things together. So now these two statements, they're actually doing the same thing, but they are written differently. And if you look at this, you find out that this is extended and this is a lot more cleaner. And with this, you can have your you don't have to have it on a you don't have to have it extending and going the other way. You can just have everything following the same pattern. So like this is much easier to read. If weather condition is equals to rain, if it is raining, press this. When you press enter, you go back, press enter and go to elif. Then it comes to weather condition equals if sunny, no. If it's sunny, do this. If it is not sunny, move to the next else if. Check the weather condition is snowy. Is it? Do this. If it is not, move to the next one, which is else. Then print. So if you run this, sorry, you find okay, you can't go out. I think that's because I have sun and rain. So let's change it to just rain. So you find that this works too. This also works. Take an umbrella. So they don't. This is not usually implemented because it is not like best practices. The first one, the second one is usually what is being implemented. So, but to use this, you have to know this elif command. So it's more of like uh, extending your L if else statements, right, and making it look pretty. Let me put it that way. Making it look very, very pretty and cleaner and less extended, less crowded, right? So basically, so that's actually what I actually wanted to introduce earlier, which was elif, this elif. So we have if this does not work, elif, elif, I can call it else if since it's a short form. So else if this, do this. Else if this, do this. Else do this. So how the that's just how the if else functions. So if you now have multiple conditions where you're checking, maybe you're checking more than one, because usually it's just one. If this is true, do this. If it's not true, do the next thing. Sorry. So I that's how I actually well that's how it's actually supposed to work, not just me. Um so I think I'm going to work on an elaborated example now to demonstrate this if edit properly, right? So let's take a look at another example. So let's look at the grading system. We grade, when I mean the grading system, I mean the educational grading system. Let's say in university where you have um, a particular grade for, let's say, 70 and above, a particular grade for uh, 60 and above, something like that, right? So let's say I'm going to store, let's say I have Damilola. So let's say Damilola has a score of 70. That means if she scores 70, I want to give her an A, right? And if she scores, so I want us to define the grading system. So the grading system is going to be like, if you have greater than 70 or you have 70, you're going to have an A. If you have from 60 to 69, you are going to have a B. If you have uh, if you have uh, 50 to 59, you are going to have a C. If you have 60, okay, maybe I should start from 80. So I'm just going to shift it. So 80 and above A, 70 to 79 B, 60 to 69 C, 50 to 59, that would be D, right? Then 40 to 49 would be E, and anything lower than 40, that's like zero. You can have minus actually. But let's say we want to have just zero, 0 to 39, then you are going to have uh F. That would just going to be an F automatically. So how do we implement this? Does anybody want to try?
Can I try?
Sure, you can go ahead.
Um, with my own what I'm thinking is maybe we'll start with the variables for, let's say, distinction equals to give the range, maybe 70, credit give 60, very good give that. Okay, then you try to set if credit is equals to this thing, print A, if this is print B, and so on and so forth. Maybe that will work also.
Okay. That was a nice try, actually. Hold on. Does anyone give it a try? Tito Kingsley.
For me, I'll question the first statement, the use of Damilola. I'm thinking we can use something else.
Sorry, I lost you there for a second.
I say we should use something else instead of Damilola, possibly generic exam scores.
Oh, okay. Oh, okay. Okay.
because we're not seeing Damilola as the only student here now. So
Okay. Okay. Good. Good. Uh, okay. There more?
I will stop here. Tito will continue.
Tito, the baton has been passed to you. Again, again.
I'll pass.
Oh, right. Okay.
You
Let's
will
see.
try.
Okay. So, well, exam score equals to 70. So, this is just supposed to be a variable that is supposed to take in any score, right? Now, we are still going to implement a conditional statement to check. So, the conditional statement will be to check that, oh, this exam score falls in this range. It's actually similar to what we did here, actually. So, I'm just going to be writing this from the scratch so you can see it. You can follow me along as I'm writing. So, I'm going to be doing a bit of talking. So, now it's going to be like, so, if, now, if I want to check the exam score now, I'm not going to start from 0. I'm going to start from 100 because I'm more concerned from 100. So, in a situation where the person has between let's say the person has, actually I can start from anywhere, but preferably I want to first check if the person has A, right? I don't want to be disturbing myself. So what I'm now going to do is I'm just going to start from the beginning. So I'll start from the very top. So if exam score, that's our variable that is storing the exam score, is what equals to what 70, and so if it's equals to, so rather than saying equals to, so what we're going to use is what greater than or equals to. So if it is greater than or equals to what 70, right? What are we going to do? What are we supposed to do? Print grade. So just print a print statement. So grade is A, or just print A, right? Now, we are not done. This person, let's say the exam score is lesser than 70. This will not, if you run this now, you just get A, right? So because it's 70, so if I put 60, you see nothing comes out. Now that means we have to add an elif. So like elif, if the exam score is greater or equals, okay, if it's greater than or equals, remember the boundary for B is 60 and 69. So we have to put, if this is greater than what 60. Do you want to say something, Kingsley?
No.
Okay. So if the exam score is greater than or equals to 60, and now and is a keyword. Remember, we did and in Excel, we did and in SQL. It means the same thing here. So and is like remember, let's use numbers. So 1 and 1. So 1 and 1 is true, right? If you use 1 and, okay, I'm using numbers here. Let me use true or false. True and true, you get true. True and false, you get false. So this is just to, let me take this away. So what I'm trying to do here is, if this true, if the first statement is true and the second statement is true, your output will be true. If the first statement is true and the second output is false, your statement will be false. So what we are trying to do here is, if exam score is greater than or equals to 60, uh and wait, hold on, I think I'm confusing myself. If the exam score is greater than or equals to 60, or lesser than, oh sorry, I'm supposed to use or here. actually, not and. So and will be both needs to be true, right? Uh oh, actually, I'm supposed to use and because actually both needs to be true. So if it's greater than 60, for instance, now if it's 63, 64, it has to be greater than 60, and uh, exam score has to be lesser than 69. Sorry, it should be lesser than or equals to. Yes. So it has to be like this because this 64 is greater than 60 and it's also lesser than 69. So both has to be true. If I don't do it like this, if I do it this way, if exam score is greater than or equals to 70, or print A, if the exam score is not greater than 70, is greater than 60. Of course, this will work actually. So let's just run this. So if the exam score is greater than or equals to 60, I think I said I was going to start from 80 actually. So if the exam score is greater than or equals to 70, print what? B, right? Then elif, so I can just keep going. If the exam score is greater than or equals to 60, print what? Print C. Then elif, if the exam score is greater than or equals to 50, print what? Print D. Then another elif, exam underscore score greater than or equals to 40, print what? Uh, print E. And the last one is elif, if so it means that if it's not greater than 40, that means probably less than, so we can just use else and say print what's f. Now let's demonstrate this. Let's I think I should just take this out, make it cleaner. So you can see C now. 64 according to this falls here and it's coming out. You're having a C. If you put let's say we want to put something like, let's say 39, you're going to see an F. If you try to put even minus this, you still see an F. And if you try to put, let's say 99, as a person very, very good, you see an A. This works also, but this is not actually the best way to do this. Although it is simple, you can say if the exam score is not greater than uh if the exam score is not greater than 80, right? Print A. If it is not, did I say not greater than? Sorry. If it's not greater than 80, it will move to the next one, right? If it's not greater than 70, that means it's starting from the top. It's checking from from the top. Now this is okay. This works, right? But like I mentioned, this is actually not a very, very good implementation. I'm going to explain why. So your grading system in your school or in schools basically is capped. So when I mean capped, the limit is 100 to 0. I should not go beyond 100 and I should not go below 0. So that means if I come here and put 100, sorry, if I put 101, I'll still get A, which should not be. If I put minus 101, I'll get F, which should not be. So then, what do I do? Okay, I can see another simple implementation around this. I can say, oh, if it is greater than, or if it is less than 100, let me see, can I even see how you go around this? Okay, I can say if it is greater than 40, print A. If it is, okay, I'm trying to see, I have a solution already, but I want to see if I can even try and bring something out and try to just use this. But I can't still see a way. There's anybody who wants to try. Just a try. Just give it a try, Uh, Tito, do you want to give it a try? Just a push.
So I don't understand your question.
I'm
I didn't
saying, do
get your
you?
question.
Oh, okay. I'm saying, in this situation now, we can't. A grading system of a school stops from 100, like stop at 0 and starts like is between 100 and 0. But this one, if you try to put 101 or minus 100, it will still work. So do you understand now? So
Yes.
like maybe if there's anything you think you can do, so you can see normally you are saying greater than equals to 80, then do this, and it checks from up to down.
Uh, I think the way you wanted to do it before, I mean, do it in a range, like exam score greater than if exam score greater than equal to 80 and less than, is it less than or equal to 100?
Yeah, yeah, actually, yeah, that's actually it. It has to be less than or equals to 100 if you want to involve 100, and if you don't want to involve 100, you just use less than equals to 100. Sorry, you just use less than 100. Okay, I think that's it. Yeah, nice one. Um, so I think I've gotten the solution already. So what we have to do is just add an extra to keep it bounded. So this time around, we'll have to add an extra statement that says and. Okay, let me leave this. Let me just copy this and come here. So I can now add an extra that says and if the exam score is less than or equals to 100. Now, doing this automatically, if I just run this, and I change my input from 101 to, sorry, 101. Of course, running this one is A, which is not supposed to be so. But running this one says what? B, which is wrong because 101 does not fall in this category. But then because it is greater than 70, that is why this one is being executed. So what do we do here? We also have to add the boundary to this by saying, oh, this one is supposed to be and exam score is less than or equals to what? 79. So that's what we are supposed to do here. So if you run this again, you see C because 101 is no longer falling in this range. It's now falling in greater than or equals to 60. So what do we just do? Let's just add, add the range to the rest underscore sorry equals to 69 then and exam underscore less than or equals to 59 and exam underscore score less than or equals to 49, right? Now this now looks like it's working. No, it's not working. 101 is not supposed to be in F. So what do we now do? We have to include another let's say what I'm just going to do now. So I'm going to put the range for the last one, which is supposed to be from 39 to 0. So to do that, I have to do elif because I'm still checking exam score greater than or equals to what 0 and exam underscore less than or equals to 39. Now if this happens, I want to print the words F. Now when did I now use else? If the score is out of this range, so if it does not fall in 80 to 100, 70 to 79, 60 to 69, 50 to 59, 40 to 49, 0 to 39, then what do I say? I could just say exam underscore exam score not in range. Please check. Oh, please make sure exam score is within 0 to 100. Now if you do this now and you use enter, you find out that exam score is not a range. So let me create a variable down here for exam score, so it's easier that way. So you can say exam score is equals to what. In fact, we can do something. We can even include it here. So just push this one down, then put exam score as a variable up here. So you could say exam score is what, 78. You get a B because it falls within 70 to 79. If you put it at 79, you still get a B unless you are at 80, which says 80 to 100, right? That's when you have an A. And if you try to do something maybe less, like a minus, you get exam score not in range. Please make sure exam score is within 0 to 100. If you try above this, you get the same thing, right? You could also go ahead to say, oh, maybe you want to give a separate command if it is greater than 100. You could say, oh, elif, if the exam score is greater than 100, print this. Then you want to check if the exam score is lesser than 0. You can add another conditional to it. So you can extend this. So say, oh, maybe I don't want to undo outside the range. I want to undo greater than 0 separately. Oh, sorry, lesser than 0 separately, and greater than 100 separately, right? You can do that. But with this implementation, this is actually very okay. And this is something as simple as this that can be embedded into a software. So maybe let's say a marking system or a grading system. That you could just do something like this, that, oh, exam score is the exam score this and that, do this. So it does it automatically. All you have to do is just run this and it works. Change the exam score, put it and it works. Change this and put it and it works. So that's how it's actually, that's how simple it is, right? Um, okay, I think actually I'm just bringing up a question. So let's say this range are entering each other. So this is greater than 80, less than 100. What if I now put this one? So mistakenly say 80 here. What happens if I run something like, let me see. What happens if I run, okay, I don't think it will be that fatal. So if I run 80, I'll still get an A. If I run 79, I'll still get a B, right? Let me see. I'm trying to look for an edge case. Okay, an edge case. Let's say I mistakenly change this to 65. You should know that there's already a mistake, because what is going to happen now is that from 65 to 79 will be seen as B. 60 to 69. So this 69 will not be evaluated. What it will be seen is 6, because it's the order in which it is arranged is the way to check it. So if I have something like 60, 67, 67 will fall in this first one, because it's the one that will be executed first. So it is first check, is exam score greater than or equal to 65? Yes. So it's already in this range. And exam score is greater than 79. It's already in this range. So it will just put it B. It won't come to this C. So the way it works is, this first gets questioned. If it is not true, it goes to the next one. If this is true, the rest don't get to be executed. You just get out of and print out your results straight. So that's the way it actually works. So okay, let me just add one thing, then we take questions and we call it a day. So what I want to add is, now taking this exam score this way, we can make it interactive, make it in a way that we can accept input from users. So rather than I'm just typing it here, then I have to run all of this again, right? We can make it interactive. To do that, we have to use a command called inputs. So as I press it, it came out, right? So input is like a keyword. So input allows you to take value from a user. So if I run this inputs, you see this box. If I press anything inside, anything, let's say go, You see go, it comes out as go. Now I can assign this input to a okay, before that, I can now, if I put a quote inside this thing, it's going to be like a prompt, like a question that I want to ask, like say, oh, please enter a number. So me putting a text is like a prompt that will be asked when the user runs this. So you see, please enter a number. So you can see it's beside this thing, this input stuff. So if I put 4 and I enter 4, it stores it here. Now I can now store this inside the variable, right? So let's say I want to store this inside record equals to. If I run this now, it's going to ask, please enter a number. If I enter 4, it's just going to put it and store it in record straight. So if you check record, you see that record is 4. Now we can use the same thing here, but before then, if you check the type of this record, now check the data type. So I did show us how to check data type. You find out that the data type here is what? A string. But what we're dealing with here is what? Numbers. So we actually need to convert our inputs here to numbers. How do we do that? We will use there's another Python keyword, int. So if I do int and I put this, whatever I put inside this, if it's a number, it will automatically convert it to an integer. If it's a string, it will not work at all. It's not going to work because it has to, according to mathematics, it has to be in base 10. So and base 10 is number, so it has to be number. So if I put 3, 4, 3, 2, you see 3, 2 come out. So now how do I solve this issue? Because it's an issue. All I have to do is take this whole thing and enclose it inside int. So it's like saying I'm taking all of this, right? I'm placing it inside int and this. So if I run this now, whatever is coming out, it will put a number inside. If I run this again and put a text, I'll get error. So that means it's now going to only accept numbers. How then do we now need this? We can now bring it and insert it into this place. So rather than do that, we can just come here and rather than put 67, right? We can take the whole of this, copy it and put it in where we have 67. So when you now do this now, it means that you can now take input from the user, put it in exam score, and check the score automatically. So it means you can change your number easily. So if I run this now, you say, please enter a number, right? What number do I want to enter? 5. F. See, print F straight. If I run this again, it asks me what number do I want to enter? 67. You can see it's having a C. If I try this again and I try 80 and I run this, you see A. So it's easier when you do it like this. It means that you can easily iterate, you can easily change your variables. You don't have to add code it and put it in. So add code is like you integrate it. You don't give the user flexibility to change variables. So I think I would like to stop here for today.